In this lesson, we're going to learn how to draw Lewis structures for covalent compounds, for molecules. When you get ready to draw Lewis structures, there are some basic rules that we need to follow to make sure that we show the correct bonding within the molecule. First thing you have to do in drawing Lewis structures is you need to identify the central atom. This is usually the first atom that is written within the compound. If not, you need to make sure that you have the central atom so that you can bond the surrounding atoms around it. If you cannot figure out the central atom, usually that information will be provided on an introductory level. Once you've identified the central atom, the next thing we need to do is you need to count the valence. You need to count how many electrons are in the outermost energy level for each element within the compound that we're trying to draw the Lewis structure for. So once you've identified the central and you've counted the valence, the next thing that we need to do is we need to bond the surrounding atoms to that central atom. To do so, we're always going to try a single bond. So always try a single bond between the central atom and each of the surrounding atoms. A single bond is one line, and this one line represents the sharing of two electrons. So you got to identify the central, count how many valence electrons you have, and then we need to bond the surrounding atoms to that central atom with a single bond first. Never try multiple bonds at this point. Once we learn how to draw Lewis structures correctly, and a central atom is electron deficient, then we'll learn how to incorporate in double and perhaps triple bonds. But always try a single bond first. So you identify the central, count the valence, try the single bond, and then we need to give the surrounding atoms an octet. We need to make sure that they have 8 electrons, and you do this by adding lone pairs, by adding pairs of electrons around that surrounding atom until they get up to the 8 that they need for stability. And then finally, if you ever have any electrons left over from the valence, extra electrons always get to go on the central atom. And when it's all said and done, hopefully the central and the surrounding atoms all have an octet. And if there's ever an atom that doesn't need an octet, we'll highlight that as we go. So let's try an example and see if we can follow these rules that are listed in front of you. Let's say that we want to draw the Lewis structure for the covalent compound PCl3, phosphorus trichloride. First thing we have to do, we have to identify the central atom. Most of the time that is the first element that is written. In this case that is phosphorus. So we're going to use phosphorus as our central atom. The next thing we have to do is we have to identify how many valence electrons we're working with. In this case there are 26. How was that number derived? Well, phosphorus is in group 5A, so this means that it has 5 valence electrons. Chlorine is a halogen. It's in group 7A, so each chlorine has a valence of 7. So since we have 3 chlorines, that would be a total of 21 electrons, 7 times 3, plus the 5 from the phosphorus gives us the 26 total. So far we have identified the central atom, and we have counted the valence, which in this case is 26. The next thing that we need to do is we need to bond the surrounding atoms to the central atom. You always want to try a single bond first. So notice I've shown a line between the central atom and each of the surrounding atoms. That line represents a single bond, the sharing of 2 electrons. So of the 26 that we've had, we have now symbolized, we have now depicted 6 of those electrons, because each one of those lines represents the sharing of 2 electrons. We now need to make sure the surrounding atoms, all of the chlorines, have an octet. So what we're going to do is we're going to add what are called lone pairs of electrons, sometimes called non-bonding pairs. So I'm going to, around each chlorine now, I'm going to add 3 lone pairs, 3 series of dots around each. So if we add in the lone pairs, you can now see that each chlorine has the 8 electrons. Each dot here around the chlorine represents an electron. So what we see here is that if you count the 2 that are being shared and the 6 dots around each chlorine, that gives each chlorine 8. So how many electrons have we used? Well, if you count it up, we've got 3 surrounding atoms, each with 8 if you're counting the shared electrons. So 8 times 3 is 24. So of the 26 that we had, we have now used 24. Now we need to make sure that if we have any extra electrons, that they always get to go on the central atom. So we had 26 total, and we've only used 24 for the surrounding atoms to have an octet. Extra electrons always get to go on the central atom. So if you place the extra electrons on the central atom as another lone pair, sometimes called a non-bonding pair, then you see that all the atoms, the central and the surrounding, have the 8 that they need. And this would be a proper Lewis structure for phosphorus trichloride.